Okay, we're going to look at a couple of problems in this section. In this case, from 26 to 29, we need to match each equation to its original graph and also match it to the graph of its inverse. So let's look at a pair of these that are inverses of each other. Here we have y equals 10 to the x. The inverse is a log equation, which should have a base of 10 as well. And so between these two, number 27 is the one that is log base 10 of x. So let's look at the graphs of these two as well as the graphs of their inverses. So starting with the exponential graph, we've been doing those for a while. If it helps, you can make a quick table of values to figure out what that graph would look like. The y-intercept is when x equals 0. So 10 to the 0 is equal to 1. And then if we plug x equals 1 in, we get 10 to the first power, which is 10. So if we were to do a quick sketch of this, we would have 0, 1 on the graph and 1, 10 on the graph. And you can see that it's an increasing exponential function. Another way to tell that it's increasing is just by knowing that the base is a number larger than 1. So looking at these four graphs, we can tell that D is the original graph. Now if we're trying to figure out what the inverse graph would look like, then we're actually just trying to figure out what the original graph of log base 10 of x is. So if we're looking at the graph of y equals 10 to the x, the inverse graph is the graph resulting from flipping the original graph over the line y equals x. So just a sketch of what that would look like if we're reflecting it over the line y equals x. We'd have something like that. And so you can tell that this graph is closest in resemblance to graph C. So C is the inverse of D. So now since we know this is the inverse equation here, that means C right here is the original graph for y equals log base 10 of x, and the inverse of that is back to graph D that we started with.